So here's an equation. Again, it's quadratic in form. So you see it there. There is a restriction on the interval, so 0 to 2 pi again. So we can factor this without doing a u substitution. You know, you just treat the sine theta like the u or the x, or, you know, you can always write the u substitution. That's not a problem, but so I'm thinking 2 sine theta times sine theta. That would give me my 2 sine squared theta. So I'm just factoring this the way I factor. Now you may factor differently. That's fine. You may use the quadratic formula, or there's other ways to factor. Okay, then I'm looking at the 1. I know it's going to be 1 times 1, and that they're both going to be negative because I have a negative 3 here in the middle. So negative 1 and negative 1. And then that gets me a negative 1 sine and a negative 2 sine theta. And so that's going to make negative 3 sine theta. So that's how it factors, and this is all equaling 0. So we have sine theta is equal to 1/2. That comes from this one. You could write that out as an equation and solve it. And then we have this one that would say sine theta equals 1. So then we're going to think about, you know, the interval 0 to 2 pi and what angles we get. So for sine theta equaling 1/2, we know sine is positive in the first quadrant and the second quadrant. And so that's going to be pi over 6 here in the first quadrant. And then over here, this is going to be 5 pi over 6 in the second quadrant. And then we think about when does sine theta equal 1, and that happens at pi over 2. So right here, you know, on the, it's a quadrantal angle. And that's the only place between 0 and 2 pi where the sine is equal to 1. So those would be our answers, and we're done.